All right. Hi, guys. Good evening. So, welcome to the sixth session of SQL. And we'll start from the point we left off in the last class. So, in the last class, which was on Thursday, we were discussing the concept of subqueries. So, we looked at the basic concept of what does a subquery mean. So, a subquery is a query within a query. And then we looked at 5 different kinds of subqueries, which are essentially different functionalities of subquery. You can say that. Now, there are two things which was left from here. Number one being in multiple row subquery, there are two operators, all and any, for which we did not look at any examples. So I'm going to give you that now. Now, understand all and any syntax is not available in Google BigQuery. So for this, only for this part, I'm going to refer to MySQL. So what I have done is I have created two tables within MySQL called manager and employee. I think they're already created. Yes, so I've created two tables, manager and employee. So manager table has three fields, ID, age, and salary, and employee also has three fields, ID, manager ID, and salary. So in manager, there are 4 rows with the first column being the manager ID. In the employee table, the second column is the manager ID. So basically, this is the key based on which both of these two tables can be connected. Now, if we go back to our subquery example here, multi-row subquery is basically a case where the inner query returns multiple entries, and then based on that selection, your outer query will run. This is the question. Sorry, Rajesh. Hello. Is there a question? Okay. All right. So in multi-row subquery, okay. So there are two kinds of operators apart from in, which can be used with multi-row subquery, which is any and all. Now, this is the subquery which we are going to use to understand any. So any, as the name suggests, means any match between the outer query and inner query. Now let's understand what this query is doing. The inner query is selecting salary from the employee table. So the employee table has 3 salary entries, 31K, 20K, and 40K. The outer query says that select all entries, those entries from the manager table, where the salary in the manager table is greater than the entries in my inner query. Now let's look at the salary information in the manager table. So you can see there are 4 rows. So the way your any operator works is basically like this. So you have your outer query, which is select star from manager. Now, where, this is the important part, where salary is greater than your inner query. Now the inner query, because this is a multi-row subquery, if I go back to the subquery here, this is saying select the inner query, select salary from employee. So my inner query will basically have 3 rows of salary information, which is going to get picked from the employee table. So 31K, 20K, and 40K. So it will be 31K, 20K, and 40K. Now, for each row in the outer query, where I'm going to compare the salary information from the manager table, it is going to get compared with all rows over here. So let's look at the first example where the manager salary is 56K. So 56K is definitely greater than all 3 of this. So this is greater than all 3 of this. So definitely this entry is going to be there. Now, what happens in any is that if any of the entries in the inner query satisfies this condition, then that entry is going to stay. So the first entry in my outer query is 56,000. Now 56,000 is greater than all of the entries in the inner query. So it satisfies all of the conditions over here. So this is definitely going to stay. Let's look at the other three, 34K, 30K, and 19K. So I'm going to write all of them down first. 34K, 30K, and 19K. Let's look at 34K. So 34K is greater than this. It's greater than this, but not greater than this. But because we are using any operator, if any of these conditions are true, then this will show. So 34K is greater than the first two entries of my inner query. So this will also be there in the final output. For 30K, that's satisfying the condition for one of the entries in my inner query. So again, because I'm using any, this is going to stay. Now 19K is less than all three entries of my inner query. So because none of the conditions are satisfied, so this will not appear. Let's go back to the query. I'm going to just run this and show you. See, the final output from manager table, only the 3 rows where the salary exceeds the entries, any of the entries in my employee table will appear. The syntax is same for any and all. The only difference is you use the all operator in place of the any operator. Now, what is the difference between these two? In any operator, if any of the rows in my inner query satisfy the condition in the outer query, then that output will remain. If you use all instead of any, all of the entries in my inner query should satisfy the condition. So let's go back and let's understand what this means. So if I look at 56,000, 56,000 is greater than 31K, 20K, and 40K. So for all of this, for all of the inner queries, when I'm comparing it to 56,000 salary from the manager table, all of the 3 conditions are true. So this will appear when I'm using all. When I look at 34K, if I compare it to the first entry of the inner query, it is true. Second, it is true. But is 34K greater than 40K? No. So that's false. So because all of the entries in the inner query is not satisfying the condition, so this will not appear. Similarly, for 30K, only the second entry of my inner query satisfies the condition. So again, by the same logic, for the first one, it becomes false. Second is true, third is false. So 30K is greater than only the second entry. So again, because all of them are not satisfied, this will not appear. And 19K is less than all 3 entries. So it's going to be false, false, and false. So it's definitely not going to come. So when I'm going to use all operator instead of any, only this input, this output will show. Let's run the query. So see, only one entry will come. So these are all and any can be used with comparison operators, and mostly it is used with greater than, less than, not equal to, those kind of comparison operators. When you use in, it's more prevalent with equal to, which we have already looked at before. Okay, I just wanted to give these 2 examples because they're not there in Google BigQuery. So that's why I showed it in MySQL. Don't worry about the codes which I'm doing in MySQL. I'm going to provide those to you in a TXT file. So you can refer to it with the class. So there shouldn't be any confusion. All right. Now, there was one. Okay, so this is where we left off in the last class. We had to start looking at different applications of subqueries. So up till this point, mostly we've used the subquery in either the where condition or when we want to add an additional field. So here, if you look at, whenever you want to add an additional column as a part of a subquery, you have to put it in the select clause. So this is the most common application of subquery that we have looked at till now. Now this example, what is it trying to do? This won't work with the data sets we have because we cannot link orders table to the employee table. So I'm going to give you a different example for this. I'm going to give, okay, before you guys get started, please create this nice table for your use. We're going to refer to this table for a couple of things today. So this you have to do in BigQuery. Okay. So when I want to use my subquery in the select clause, let's say I want to add the total count of employees for each department ID to the department table. So I'm going to retain the department name from the department table. Then let's say I also retain the department ID. Now the count of employees will come from the employee table. So for that, I'm going to use a subquery. So I say select count star from employee table. Employee table and E1. Now this is going to give me the count for all of the entire count. Now I want it by department, so I'm going to use a condition here where E1 dot department ID is equal to E2 dot department ID. Okay. Let's also give it a name, emp count. Now last, we have to give the table from which we are referring these two columns. So that's coming from the department table, and the alias for that is E2 because it is going to get used in this condition over here. Let's run this query. So see, we retain the department name and department ID, and the employee count came in from the employee table. So here we are using the subquery in my select clause as a part of the select clause. What's the next application here? The next one is in the where clause. Now this is also a very common one. I think this is more common than using it in the select statement. So this is similar to the example which we just saw. So here in the where clause, we are using the subquery. So the subquery is getting used to basically filter out the data from the entries in the main query. Again, this query will not run because location does not come from the departments table. Sorry, one second. Yeah, doesn't come from the departments table. So we've looked at a lot of examples on where clause. So I'm not going to spend time on that. Let's look at the third one, where subquery is in the from clause. Now this I don't think we've looked at. So what is happening in this query? Let's understand that first. So the trick to understand a subquery is first look at what's happening in the inner query. So in the inner query, if you see, by department ID, we are finding the average salary, correct? And that's coming from the employees table because salary information is sitting in my employees table. Okay, so this is going to give me the average salary by department ID. Now, this entire thing is a table. So if you think of it, the output of the inner query is going to be for each department ID, you get the average salary. Now we give an alias to that, which is called department average. So this inner query is going to be called department average. It's a temp table which is getting created. Now to that, we are joining the departments table on the department ID key, and we are adding the department name from that. So this is similar to what we did in the first example. So I'll just copy this out as well. Let me paste this query. Let me just quickly fix the name and everything. Department name, ID, salary. Let me just copy this out from here. Instead of employees, we call this department ID, has a underscore, and then the departments table is supposed to be called like this. Okay. And again, department ID has a underscore. Okay. So here, let's run this query and see the output. It will be clear what's happening. Department. Unrecognized name departments. Where is that? Oh, okay. Let me call this D. Okay. So what happened here? In my previous example, what did I do? With department name, I added the count from the employee table. And here I added the subquery in my select statement. Now in this query, also a similar action is happening. For each department name, I'm finding the average salary from the employee table. But instead of adding this information to my select clause, I'm putting it in the from clause. So the same functionality is happening. The logic happening is the same. But instead of adding it in the select statement, I'm adding it in the from clause. Okay. Let's look at the last one. This is pretty simple to understand. So here subquery can also be added to the having clause. So what's happening here? Here, this is happening on a single table, on the employee table. So on the employee table, by department ID, we are first finding the average salary. And then we are going to filter it out based on the average salary. So wherever the department's average salary, so the average salary by department ID, wherever that exceeds the overall average from the employee table, those rows will get selected. Let me run this out for you. Again, we'll have to change the names a bit. Instead of this coming from here. Okay, department ID and right. Okay, so just to understand that, if I simply run the inner query, so the overall average of salary in the employee table is 75.6K. This is the output. So wherever the department's average salary exceeds this number, only those will show up. If I just run this part of the outer query where this clause is not selected and I run it, if you look at the output, now the overall average was 75 point something K. So see, 1 will not show up, 3 will not show up, 5 will not show up, and so on. Let's see if that's true. If I run the entire query, so here, based on the average salary computation, the filtering will happen. Now, because it's happening on a aggregate function output, so that's why we'll have to put it in having and not in where. This is basic having where differentiation, which we looked at earlier. See, only those entries which exceed that 75.6K, which is the overall average of the employee table, only those rows will appear. Okay. So those are kind of the 4 places where you can use a subquery: in the select, in your where, in your from, and in your having. Okay. Now there is one last kind of subquery which is not covered as a part of your content, but I'll still may explain it to you. So that's called a nested subquery. So a nested subquery means where you have a subquery within a subquery. So up till this point, we have a single subquery. So this is my inner query, correct? Now within this query, if I have another query, then that becomes a nested query. So I'll just give you an example. I think I have the ERD open. So in this ERD, I'm going to refer to this database. So let's say I want to pick those orders from my orders table, which cater to category, let's say jewelry. So I will have to first create a subquery using order details. And then within that subquery, I have to create another subquery using products table. Okay. Let me do that. So first I'm going to write the outer query. So let's start from orders. Okay. Where order ID in. Now the middle table between orders and products is order details. So let's say select order ID from order details. Order details. Now we want to pick those orders which cater to the product category jewelry. So category comes from my product table. So where product ID in. So I'm writing another subquery within this subquery. Select product ID from products table. Products table where category is equal to jewelry. So this is my innermost query. If I run this query, this is going to give me those product IDs catering to product type category jewelry. So I think there'll be some 9 product IDs catering to jewelry. Now, if I run the first inner query with the second inner query, I'm just breaking it up for you. So now, if I just run the selected portion, what's going to happen? Those order ID from order details will get filtered where product ID falls in these 9 product IDs. Sorry, these 11 product IDs. There are 11 product IDs catering to category jewelry. So if I run this bit of my query, so those order IDs where the product IDs match these 11 product IDs will get filtered. Let's run it. I've not kept the product ID, but if you go back and check, these product IDs, these order IDs will exactly cater to the product IDs for category jewelry. And then finally, the final output from orders table would be filtered on these 1671 order IDs. So if I run this part of the query, which is the entire thing, sorry, scroll up, run. See, these order IDs are getting filtered out, those 1473 orders. So what's the difference? What's the specialty of a nested subquery? It's nothing but when you have a subquery within a subquery, you can have n number of subqueries within one subquery. So instead of this where I can have another subquery in it and then another, so something like that. So this is called nested because within one subquery, I am nesting another subquery. That's the only thing. Okay. So that completes the initial aspect of subquery. There are going to be 2 concepts of subquery also. One of those I think I'll cover today, which is called a derived table. And the other is going to be a CTE, common table expression, which I think will take up on day 8. But think of it as more advanced versions of subqueries itself. Okay. Okay. There is quite a bit of questions in your classwork, in your SQL practice questions also, which cater to subquery. I suggest you guys have a look at those and look at the solutions if you're getting stuck, and let me know if you have any other doubts there. So for day 5, these are the 6 questions which we wanted to solve. So let's go back and solve them. So we're going to call them day 5 solution. First question is, find the entries in products table whose price is less than the average price of all listed products. So all entries in products table, so it's going to be select star from products, that's my outer query, whose price is less than average price of all listed products. So here, this is going to be a simple non-correlated query. Let's write it out. So select star from products where price is greater than select average price from products table. This is a pretty simple one. So this is going to give me the overall price average, the inner query. Wherever the individual price of a product exceeds the overall average, I want those. So I'm going to go select this and run this query. Scroll this up. So see, you get 23 entries. If you want to confirm, I'm just going to sort this price in ascending order so that the first entry here has the smallest price. So the smallest price is 249.99 based on the output of this subquery. If I run this part of the inner subquery, which is the overall average, that will exceed 249.99. So see, the overall average of price is 211.58. Okay. Simple. Question 2. Add the minimum price to all entries. So here I want to add an additional row. So because I'm going to add it, this is going to be a part of my select clause. So I'm going to say select star, comma, select min price from products table as min price, and then the star is also coming from the products table. So in the outer query, I have to mention the product, the table name from which I'm going to pull all the information. Just simply I'm adding this min price column. So this will create a new column in my products table. So see, 100 rows of information, which is exactly equal to the number of entries you have in the products table. These are the 4 columns which are coming from the raw table, and this is the minimum price. Because I'm taking the overall minimum price is 4.99. So we just append the minimum price as an additional column to my products table. Question number 3 is find entries from order detail table which have products excluding categories, tools, and furniture. So here categories will come from the products table, and my outer query refers to my order details table. So I'm going to say select star from order details where product ID in, then my inner query, in my inner query, we want those product IDs. The question says products excluding category, tools, and furniture. Select product ID from products table where category, now I want to exclude 2 categories. So I'm going to use the in operator and I want to exclude them. So I will write it as not in. So I'm combining the in operator and the not operator. The 2 categories are tools and furniture. Okay. If you run this query, so if you go back and check, all the product IDs which are listed here will not cater to the category tools or furniture. So it is going to cater to the categories apart from tools and furniture. Okay. Question number 4. Find distinct category from products table based on products ordered in order ID 1. So we want to filter category. So we want to create those distinct categories from products table based on products ordered in order ID 1. So here in my outer query, my table being referred to is my products table. So let's write that out. Select, we want distinct category. So I'm going to write distinct category from products table. Where now in my inner query, we want to only filter out those products which cater to order ID 1. So the linking key between these two tables is product ID in, select product ID from order details, where order ID is equal to 1. So if I run this query, this is going to give me those product IDs which are placed in order ID 1. So there are 5 such product IDs, 27, 31, 37, 59, and 64. So with this where clause, this will give me only those categories which cater to these 5 product IDs. So there are 4 such categories. If you go back and check, this will exactly match the 5 product IDs which cater to order ID 1. Okay. See, in most of these questions, we mostly use either we use it in the where clause or in the select clause. The 5th question is, we want to retain from products table, we want to retain those products which are priced higher than the average price for that category of product. Okay. So from products table, we want to retain products. So the products table is going to be referred to in my outer query, which are priced higher than the average price for the product category. So because this is going to refer to the average price group by category, we will have to use a correlated subquery. Okay. So let's write out the outer query first. Select star from sorry guys, I just got a message. All right, from products table. Okay, let's give it an alias P1 where price exceeds select average of price from price is also coming from the products table only. So we'll refer to the same products table. We're going to give it an alias P2 where P1 dot the key between both of these tables is product ID. Sorry. The average has to be on the category. So this has to be on category. Okay. Yes, so let's run this and see. Okay. So what's happening? If I just sort this by category. So for electronics, we have these 9 entries, and for all of them, the price is greater than, I think, 299. The lowest price in category electronics, which is getting filtered based on the query, is 299.99. So what I'm going to do is compute the average price by category to make sure that the query is working correctly. See, when you're doing, I'm doing this for your sake so that whatever I'm doing makes sense to you. But whenever, let's say you're coding for the first time and you're working on subqueries and you're not sure if it is going to work or not, just break down the subquery, break down the logic and check for a couple of cases if it is working or not. So based on this logic, if the average price for category electronics is anywhere less than 299, that means the logic is working correctly. So let's check that out. So for electronics, hold on, the average price is 508. Oh, sorry, I used P1 and P1 here. Okay, I'm sorry guys, let's run this again. So we know for electronics, the minimum price is 508.45. So if I run this again, I had used the same alias P1, which is why I think we got a slightly wrong answer. Okay, let's go down to and check out electronics. So for electronics, see the minimum price which is getting filtered out is always greater than that 500 something value. So the minimum price of electronics getting filtered as a part of the subquery is I think 699. Yes, 699 is the lowest it goes. So because the average price for electronics was 500 something, 594 I think, so then the query is working correctly. So here I'm using the subquery as a part of my where clause. And why is this a correlated subquery? Because for each entry of my outer query, which is each entry of my products table, it is going to look at the category and then compute this logic for each entry of my outer query, then compare the price of that entry with the average price for that category, and then decide whether that has to be kept or not based on the selection clause. Okay, so that's why this is a correlated subquery. Okay. Now in the last question, this question I think I've given you as a part of your join exercise also. What I'm going to do that now is solve it using a subquery also. So remember that you can do multiple things with the same, so you can do the same thing using multiple techniques. One way to solve this question is using join. Using subquery also we can do this. So let's see, what do we need? From products table, we need to retain product ID, name and price. So let's write that out. Select a dot product ID, a dot product name, comma a dot price. And then from the other one, from order details, we need to retain total quantity of products placed. So we have a quantity field, we need to take the sum of that, and total count of orders placed. Okay. On product ID. So because there are two separate aggregations here, one is adding total quantity, other is adding total count, we will have to use two subqueries, one for each calculation. Now because I'm adding two additional rows, this is going to be in the select clause. So I will say select sum of quantity from order details. Select this table. B, where A dot product ID is equal to B dot product ID as total quantity. And now I'm just going to copy this same thing and paste it as a new subquery. And I want to count the total number of orders for each product ID. So we'll just say count star from order details B, where product ID this, and the name would be total order. And then in the outer query, I have to refer to the products table because these fields are coming from the products table. Products, and the alias that I'm using is A for it. See, from products table, I'm pulling these fields and the alias is A. So now if I go and run this query, see, there's a total quantity and total orders. So this is giving me the sum of total quantity, sum of the quantity column for each product ID. So think of it like in my order details table, if I do a sum of quantity group by product ID, then that will give me this. Similarly, if I do a count of order ID or count star based group by product ID, then I will get this output. Now, what's happening here? Because for each product ID here, for each entry of product ID in my products table, this computation happens again and again, both of these computations. So that's why this is a correlated subquery. And because I'm adding two new columns to the products table, So this is a part of my select clause. Okay. The reason I showed you this example is, number one, you can do the same thing using either a join or a subquery. And second, when you want to add multiple fields in my select clause using different aggregations, you have to add two separate subqueries for it. This is why I wanted to show this to you. Okay, so this solves all the questions which were pending for day 5. And that also completes everything that was present as a part of the basic SQL section. So now today we move on to the advanced SQL topics. And today I'm going to not delve into too much of advanced topics. We're going to look at slightly intermediate topics. So if we scroll down, this talks about all the things we are going to cover here. And first is an overview. This is basically a snapshot of all the things that you did as a part of your basic SQL modules. So I suggest you guys go through this. Then comes window functions, which I'm going to cover on Thursday in the next class, because this is slightly advanced. What we are going to do today first is look at 3 separate categories of functions based on the data type on which it is acting. So string functions, date functions, and numeric functions. The only thing that you need to keep in mind when you're looking at any of these functions is that these are row-based functions. So they act on each row separately. Okay. If you remember the aggregate functions which we had looked at, which is sum, average, min, max, those are aggregating. So those are summary functions. And these are called row-based functions. This distinction applies to any tool which does summarization. So be it Tableau, be it SQL, be it Excel pivots, this differentiation applies. Okay, so I'm going to strictly stick to the functions which are present as a part of this PDF, or this mota covers the things that you should know. But remember that there are going to be a family of other functions, and the syntax for that will differ from tool to tool. So let's say in BigQuery, if the syntax is X, in MySQL, it might be slightly different. And that is an adaptation you will have to do based on the tool that you are going to work on in future. The idea here is to introduce you to the concepts of as many row-based functions as possible at your level. And so you understand how that is applied. Okay, so first we are going to look at 3 rounding functions. So here we have round, ceiling, and flooring. So round is it's a universal function which is present in all coding languages. So round basically rounds up the number to the required decimal place. So the example here says that if you have 4 decimals and you mention that the total number of decimal places you want as 2, this number will become like this. Now ceiling and flooring, both of these will round up a number to the nearest integer. So you have to only specify the number that you want to round up or down, and then it is going to round it up. So 123.45 will become 124 when you use ceiling. And if you use flooring, this will get rounded down. So it will go to 123. Let's quickly code it up. So I'm going to call these as numeric functions. And I'm going to refer to the salary field here. So I'm going to say select salary, round salary. Let's say we keep it to 1 decimal place as R&D salary. Then I'm going to use ceiling salary as salary. I'm going to create a single code for this because it's the same logic. We are just trying to see if we understand it correctly. Sorry, employees table. Yeah. So I've kept the raw column, which is salary. Then I'm using the rounding, which is going to keep it rounded up to 1 decimal place. Then it is going to round the number to the nearest integer just greater than that, and flooring will round it down to the nearest integer. Sorry, I don't think it's called floor. It's called floor only. Am I doing something wrong? No. Right. So if you just look at one of these rows, so see, this number gets rounded to the nearest decimal point 1. So for the first one, because it is 0.72, it goes to 0.7. For the second case, because it is 0.07, that gets rounded up to 0.1. Okay, so rounding is simple. Ceiling will always round the number up. So it will look at the integer part of it and then add 1 to it. So 53446 will become 53447. Okay. Now, because this number has a decimal point, it has 0.72. So my flooring will always take it to 53446. Okay. If there is any number which does not have any decimal point, like this one, this also has a decimal point 0, by the way. So it's always going to take it to the integer number itself when you use the floor option. Okay. So these are pretty simple concepts, so we'll not spend a lot of time on this. The fourth numeric function here is mod. Mod is also a universal function. So mod gives me the remainder of a division operation. So the first number in my mod function is going to be the number that I want to divide. And the second number is going to be the number by which I want to divide it. Okay. So let's say in this same function, I want to check if my salary is divisible by 2 or not, or if it is an even number or not. So I will say mod salary, which is the number, the dividend, and then the divisor is 2, because that tells me if the number is even or odd, as even, odd indicator from okay, there is a problem. I cannot use this because I'll show you what's going to happen if I use this. I'll just write it out. I remember now. So if I run this in BigQuery, it's going to give me an error. Yeah, this is happening because if you look at the error here, it says that in my mod function, I will have both the divisor and the dividend have to be of the same data type. So either both of them have to be integers, or both of them have to be, big numeric is nothing but decimal number. That's the data type in BigQuery for floating numbers. Now we know salary has decimal. So basically in my mod function, I'm using one integer and one decimal number. So then it is going to give me an error in BigQuery. So for this, what I'm going to do is I'm going to use a different function. Even if I try to round this number and then use it, no, still it is going to give me this error. So I'm going to use a completely different thing. I'm going to use a summary function. Say sum of quantity, or actually I can just use quantity. Because I know quantity is not a decimal number, it's a even number. Sorry, it's a integer, as even, odd from products table. If I run this, now because quantity, order details. So see, I did not retain this number or what? Nice. 150. If I retain this, it will be easier to understand. If I run this. So whenever the remainder of this is 1, that means it's an odd number. Whenever the remainder of it is 0, that means the quantity is an even number. So the mod is giving me the remainder when I divide quantity by the divisor, which in this case is 2. Okay. So these are the 4 additional mathematical functions which we wanted to cover. Let's look at string functions now. So under string functions, we are going to do some manipulations based on the string fields which are available to us. All right. So the first thing that you can do with strings is you want to concatenate or string along 2 or more than 2 strings. So what I'm going to do is string functions. In my customer table, I have my email and phone number. Let's say I want to create one field which combines both of them. So I will say select name. I'm not sure how the fields appear. Let me quickly check. So this is my customers table. So it has name, email, and phone. I'm going to say select name, then concat. First, I want the email. Then I want a separator. So if I want to add a string, a hard-coded string, let's say I want this double slash in between it, and then the third as PII from customers table. Right. So here what's going to happen is first the email for each row is going to come, followed by this sign and then the phone number. For each row, this function will execute. Let's see if that's happening. If I just expand this out, see, this is the email ID, then the double slash and then the phone number. So anything that you put between quotes will also be treated as a string. The next string function is length. So length is also universal. Length gives you the length of a particular string. So if I say, I'm going to copy the same function because every time I keep writing the name of a table, it takes a while to actually execute it. So I'm going to remove this and say length of name. Length of name. Okay. So this is going to count the total number of literals which are present in name, including spaces, and give it to me. So Hunter Farley has 6 letters in the first name, then a space, and then 6 letters in the last name. So total adds up to 30. Okay. Now, the third one is a substring. So a substring is something which is used to extract a part of the string. Okay. So the syntax for a substring function is first you have to say the field from which you want to do the extraction. So the main raw field. Then you have to specify the start position of from where you want to extract that substring. And then you have to specify how long you want to extract. So if in this example only, I want to extract the first name, and let's look at the first example. So in substring, my first argument is going to be name because that is the column name, followed by the starting position. Now I want to extract the first name, so that will always start from the first position. So my second argument in substring function will be 1. The third is the length, how long I want to extract. So in my first entry, my first name is 6 letters long. So the third is going to be 6. So let's write it out. Substring name, starting position 1 for first name. And here the length of the first name is 6 letters. So I'm going to say 6 as first name. Okay. Now if I run this, see, this is doing it correctly. For KC also it is correct because actually not correct. It is actually also combining the space after KC, which we cannot see. But in the case of Kathleen, it is only substringing or extracting the first 6 letters from the first name. So KATHLE is getting extracted, which is not the complete first name. So we have to somehow automate this 6. 1 is okay for first name because first name will always start at the first position. But we have to somehow automate the length of the substring. Now, for that, we are going to use another function. Let me first explain that to you. It is called INSTR. So what is the one feature which is common in all of these names? The separator between my first name and last name is always a space. Yes, space. So if we find the position of the space and then use it somehow to automate this third length of substring, then that should work. So for that, you use the function called INSTR. So in INSTR, first you have to mention the field name and then what is it that you're looking for? Think of it like a find function. So within the string name, I'm trying to find a space, a single space. Okay. Let me just run this query and look at whether it is correctly identifying it or not. See, so the space position in Hunter Farley is the 7th position, which is correct because the first name starts from 1, ends at 6. So the space is the 7th position. In Casey Rogers, it is the 6th position because Casey is a 5-letter first name. So this space is correctly, this position of the space is correctly getting identified using this. So instead of using 6, if I copy this function, paste it here, this is still not complete because it is giving, if I say the length is 7, it will always combine that space with the first name. So I'm going to say -1. When I do -1, what is the output of this? This is going to be 1 minus the position of the space. So for this case, it will become 6, which is exactly equal to the length of my first name. For this case, it becomes 6 minus 1, which is 5, which is the length of the first name here. Is it correctly happening for Kathleen? So Kathleen is an 8-letter first name. So 9 minus 1 is 8. So that should correctly work. Let's see. See, now it's correctly working for all of the cases. Now what I want you guys to do is use the same concept of length, INSTR and substring and find the last name. It should be simple. I mean, this is kind of universal across all coding languages. Give it a try. If that doesn't work, I'll help you with it. Okay. All right. So that's a small homework that you guys should try out. Find the last name like we found the first name. Okay. The fourth function here is a replace function. So as the name suggests, within a particular string, if I want to replace one substring with something else. Okay. So let's use the same example. So here in the employee name, I want to replace the space with a underscore. Okay. Is it name? I don't remember if it is name. It is name, not employee name. Okay. Right. So in the name field, I want to replace a space with a underscore from employee. If I write this like this, select the name. Let's see. See, instead of the space, now there's an underscore between the first name and the last name. Okay, so replace is also pretty simple. Now I'm going to show you one conditional function, which is case when, and it is used a lot in SQL. So let's say I want to create a bucket on top of my field salary in my employee table. And I want to say that if the salary is less than 40K, then put it in bucket 1. If it is between 40K to 45K, then put it in bucket 2. If it is between 45 to 50, put it in bucket 3, otherwise bucket 4. So let's say I use the field name salary, then case when, this I'm showing you so you understand the syntax of it. Salary less than 40K, then A dot bucket 1, else, sorry, you don't have to use else here, when salary is less than, now this is sequential in nature, so I don't have to put both sides of it. What I mean by that is, because all of the entries for which this condition is satisfied, because they'll already get this assigned, this bucket value will get assigned. So here I don't have to specifically say where salary is greater than 40K and less than 45K. I can simply use this functionality and it will work. This applies to any if else, case when statements. So I think you guys will be conversant with that logic. C dot bucket 3, and then everything else goes to bucket 4. So once I have assigned all the cases, the last is whatever is remaining will go to bucket 4. So essentially all cases where the salary exceeds 50K will go to bucket 4. Now I have to give a name to this. So you say end as, and then the name that you want to give it. So bucket salary from employee table. When I run this query, you see, this exceeds 50K, it goes to bucket 4. This is bucket 1 because it is less than 40K, and so on. So using this, you can create additional fields. You can also use it on top of aggregations, but we're going to stick to only the basic understanding of the syntax for now. Okay. Is all of this clear? I'm going a little fast on this because these are very uniform concepts which you have worked on in Python. Most of these you've also looked at in Tableau. So conceptually, there's nothing new. It's just about understanding the syntax of it and applying it in SQL. And because these are again row-based functions, so there's not a lot of complexity in this. That's why we're going fast in this part. Okay. So now I'm going to talk about, there is one more string function which I'm going to talk about when I'm doing self-join, because I need a specific data set for that. Okay. So I'm going to explain that to you when I'm doing self-join. We're going to do that today itself. Let's first look at date and time functions. So date and time functions are useful for manipulating date and time fields. Some of the common ones are date add, date diff. We'll also do date truncate. Then we're going to look at, instead of get date, I think the function is different in this. Okay, let's start from the beginning. Date add adds a specified number of units to a date. So remember that the syntax that you see here is the one that is, I think this is compatible with MySQL, but the syntax in BigQuery differs slightly. So I'm going to show you the one in BigQuery. The logic is the same, so shouldn't be difficult to understand. So just clean up the space. Okay. So there's a field called hire date in my employee table. We're going to refer to that. Hire date. Then I'm going to show you date add. So date add adds a certain number of days. You can also use it to subtract. So let's say I want to add 1 month to my current hire date. So first you have to mention the field to which you want to do the addition. Then by how many? So I want to add 1 month. Okay. So you say it in BigQuery, you write it as interval 1. And then I want to add 1 month to each hire date. So you say interval 1 month as hire date 1M. Let me also add 1 by week. So hire date I want to add 1 week to each hire date. So I'm going to say 1 week. Similarly, you can do it for 1 year, 1 quarter. Yeah, you can do for all. I think for weekdays also you can do it, but that's a little too granular, so we'll not go there. I'll show you the -1 also. So let's say I want to subtract 1 month from the hire date. So I will say hire date interval -1 month as hire date -1 month. Let's see if this is aligned to our understanding of DATAD or not. Okay, so first, this is exactly the first one, adds 1 month. So see, all of these are exactly 1 month ahead of the original hire date. 1 week will add 7 days to the hire date. -1 will take the hire date and subtract 1 month from it and give you the output. Okay, so using DATAD, you can add or subtract X number of date interval from a particular date field. The next is date truncate. This is not there as a part of your function, so I'm going to explain it to you. Date truncate truncates your date to the beginning of the month in BigQuery. In some RDBMS tool, it truncates to the end of the month. So because we are in BigQuery, I'm going to stick to that. So hire date trunc. In the function, first you have to always mention the name of the field that you want to truncate, and then by what you want to truncate it to the month beginning, year beginning, quarter beginning, what. So I want to truncate it to the month beginning as hire date dt begin M. Employee table, and it. See, it's truncating it to the beginning. Small homework for you guys. If I want to truncate it to the end of the month in BigQuery, think of what you can do. Don't spend a lot of time on it, because in most other tools, date truncate function takes it to the end of the month. It's only in BigQuery, I think, where it takes it to the beginning of the month. But let's say for conjecture purpose, let's say truncate is taking it to the beginning. How do you take it to the end? Now, keep in mind that some months have 30 days, some have 31 days. So how do you do it? Think about it. One hint, you will have to use DATAD and then do a small tweak to it. Okay. The third function in date is dateDiff. DateDiff gives you the difference between two dates. So let's say I want to find the number of years between the hire date and the current date. So before that, I have to tell you the function which you use for current date. In MySQL, the function for that is getDate. In BigQuery, it is current date. Okay, so if I say current date, then I say hire date, and then I say dateDiff. Okay. So first I have to give the starting date, sorry, the end date or the bigger date. That's how I remember it. Current date, hire date, and then by what interval you want to find the difference. Let's say I want to find the month difference between these two from employee table. So see, this is your current date, 12th of November 2024. This is your hire date. This is giving you the number of months between them. Okay. I can choose day, I can choose week, I can choose year also. But remember, it's always going to give you the whole number. So here, if I say year, and I run this, keep this in mind that it is only going to give you the whole number of years. So although the actual number of year difference between this and this is greater than 7, this is May 2017 and this is November 2024, so it's 7 point something, but it is only going to give you the whole number of that year. So remember this whenever you're using date diff. Okay. We've already looked at current date. So the function that you use in BigQuery to find the current date is current date, and in MySQL it is get date. Format is used to format a date time value to a specific format. Okay. Now this format is applicable in MySQL. It differs a bit in BigQuery. So I'm going to say select higher date, and then I'm going to display this with a different format. So format higher date, and then let's say I want to show it as 12th November 2024. That's how I want to show it. So the way I say that is %d, date comes first, hyphen %b hyphen %y. So the way you specify your format also differs from tool to tool. I'm showing you the one which is applicable in BigQuery, and I'm just going to show you one of them because there's not, sorry, it's not called format, it is called format date here. So the function name is also slightly different. Okay. So the idea is that you understand how to work this. Hold on. String date time. Oh, higher date is a, okay, I'm going to use the current date. I don't know why we are getting this. I'm going to spend some time on this and tell you why I'm getting this error. But just to explain this and close this topic for now, because this is a pretty simple thing. No matching format. Am I getting the format wrong? Okay. It's the reverse of it. These are small formatting things. Even if you Google it, you'll always find answers for this. See. So now, for each current date, this is the format. So the format that I'm using here is first day and then B. B denotes the month in 3 letters instead of 11, 12 that way, and then Y. Okay. So we have understood how do you use different kinds of formats in dates. Now, okay, we have some time left and we started a bit late, so I'm going to extend the class a bit today. What we are going to look at now is self-join and cross-join. There is another kind of join apart from the 4 simple joins that we had looked at earlier. So, first I'm going to explain cross-join to you. Let me pull this down. Cross-join will give you the Cartesian product between 2 fields that you're mentioning here. What is Cartesian product? Cartesian product is nothing but all combinations between all values of those 2 fields. So one thing in cross-join is you don't have to mention any key on which the tables have to be joined, because you are trying to find all combinations of 2 keys. Let me create it and show you what I mean. Select, I'm going to refer to 2 simple tables, small tables basically. B.name as publisher. So I'm going to use 2 tables which are not related directly. I'm going to use my authors table and publishers table. So if you remember from your ERD, you cannot really link those 2 tables. So authors table, if you want to link it to publisher table and you use a conventional join, you'll have to go this way. But for a cross join, I am going to refer to all entries of this name column in authors and the name column in publishers and find all combination between these 2 fields. So from authors A cross join publishers B. That's it. I just have to mention it like this. No key required in cross join. Okay. So what's happening? How many entries am I getting here? If you remember, both of these tables have 5 entries. So you get a total of 25 entries because each entry from my table 1, which is my authors table, these are my author names. These are the 5 unique entries. They are forming a Cartesian product or a combination with all entries from my publisher table. So these are the names from the publisher table, these 5. See, George Orwell is getting mapped to all 5 of them. Harper Lee is getting mapped to all 5 of them. Similarly, the other 3 is happening. So a cross join is used when you want to find the Cartesian product between the 2 tables. Okay, no key required. So think of it like if your table 1, field 1 has 5 entries and table 2, field 2 has 6 entries, then the total number of entries that you will get when you do a cross join is going to be 5 into 6, 30. Okay. Cross join is useful when you want to create a structure. So this is useful when you want to, let's say you're doing a reporting, okay, and in that reporting you're referring to an orders table, and in an orders table you can have orders starting from January 2020 to, let's say, December 2023, but in that orders table certain months are missing. Okay, so if you do a group by that order date, certain order dates will be missing in that group by field. But when you're doing a reporting, you want all dates to appear, even with, let's say, the total number of orders reported as missing or 0. So in that case, a cross join gets useful to create that structure of all months and all years. But that's an application that I used a lot. For cross join, just remember that based on the fields that you're specifying here, it is going to simply create a combination of all entries of those 2 fields and give you the output. Okay, now let's refer to self-join. So self-join, as the name suggests, it's a regular join only, where you join a table to itself. If you look at this example here, you're joining your employees table to employees table itself. So employee join employee on department ID, and then you're joining some other table. So there is no keyword for self-join. You're going to use the 4 conventional joins, which is inner, left, right, and full join. It's just that you're going to keep referring to the same table on the left as well as right. Now, it's about when do you use self-join. So self-join is useful when you want to, let's say, when you want to refer to a hierarchy. So if you run this query, you won't really see any, I mean, it's not a good explanation or a good application of self-join. I'm going to show you 2 very basic applications of self-join now. And for that, we are going to refer to that table, which I pasted at the very beginning for you here. This emp manager table. I already have it. So let me quickly show that table to you. Emp manager, come on up here. Sometimes it doesn't show up. Okay, let me run this. This is a pretty interesting concept, by the way. It's not. Okay. So let's start from, sorry. Okay, let's look at the table now. So there are 6 entries. So there are 6 employee IDs. This is their name. This is their salary, and this is their manager ID. So this manager ID says that Sarah, whose employee ID is 1, her manager's employee ID is 5. So if I scroll down, I can see that actually Sarah's manager is Aaron. Similarly, for Todd, again, the manager ID is 5. So for Todd also, the manager is Aaron. Then if you go to John, John does not have a manager. So maybe he's the top level. Maybe he's the CEO. So that's why he doesn't have a manager. For James, whose employee ID is 4, and for Aaron, whose employee ID is 5, the manager's employee ID is 10. Now that doesn't exist in the current table. The entry for employee ID 10. Okay. Now for Maggie, the manager's ID is 2. So that means Maggie's manager is Todd. Now to understand that, I had to manually look at the table. What if I want to create a table where for each employee, I'm tagging the manager also. So here I will have to join this table to itself, and I'm going to use a logic for it. Okay. So if from my first instance of employee manager table, I want to retain employee ID and name. So I'm going to call it employee ID a.name. Okay. From the second instance, I want to retain the name of the manager, not the manager ID. So I will say b.name as manager name. Okay. Now my first table is employee manager. From here. The alias is A. Let me just say join. Now, because this is a self join, I have to refer to the same table, B. Now, the whole game is how do you specify the join key. So, if you look at this carefully, wherever the employee ID becomes equal to the manager ID. So, the manager, I want to pull the manager information for each of these employees. So if the manager ID from my table 1 is equal to the employee ID from table 2, then I should get what I need. Let me code it and show you. On A dot manager ID is equal to B dot emp ID. Let me run it first. Now, by default, this is a join. Whenever you just mention a join, it's an inner join. So it will only give you those cases which are exact matches. Let's keep a left join so that all entries from my raw table are retained. Okay. So what's happening here? If I just sort this. Okay. So if you remember from my original table, employee manager table, for Sarah and Todd, the manager ID was 5. And for 5, we know that the name is Aaron. And for Maggie also, we remember that the manager ID was 2. So that's why Todd is his manager. For James and Aaron, the manager ID was 10 because that had no matching entry. So based on this condition, it's going to give me null. And for John, there was no manager ID only available in my table. So it gives me null. Now, what's happening in this logic? So think of it as this as my first alias. Okay, so in my first table, I'm referring to the employee manager as my employee table. In my second alias, I'm referring it to as the manager reference table. So wherever the manager ID from my employee table is equal to the employee ID in the manager reference table, that should give me the manager name, which is exactly what we are doing. So that's why I'm getting the correct manager name. But I don't like these nulls here. I want to use a particular, I want to call this as no matching manager found. So here I'm going to use a function called collace, which is a string function. So Coalesce basically does this. Manager found. Wherever it doesn't get an entry for this, a valid entry for this, it is going to take the second entry from here. So think of it as string 1 and string 2. So wherever string 1 is present, for whichever entries, it is going to take the value for that string. But for those cases where this is going to give me a null, it is going to take the second string, which is no manager found. Let's run this. See, for these three cases, no manager found. So Coalesce function is useful when you have missing values in your string data columns, and you basically can specify a particular user defined value if this gives you a null or a missing. But Coalesce only works with string function, string data. Remember that. I'm going to give you one more example of this. So if I run this table again, let's say I want to conduct a secret Santa. Okay. So in a secret Santa, for each employee, another employee becomes a secret Santa. Correct? So for all of these employees, he himself can never be the secret Santa. I want to find the combination of Sarah with all other employees sitting here. I want to find the combination of Todd with all other employees sitting. Okay. So then I'm going to use the concept of self-join. Select a.name as child and b.name as secret Santa. From, I'm going to keep using the same, no, not this logic. Now here, class work dot emp manager a. I'm going to use a simple join here. Class work dot emp manager b on. Now, what is the logic on which I want to join this? That in no case my name coming from first instance of employee manager should be equal to the name coming from second instance from my employee manager. So this name and this name should never be same. Correct? Because the same person cannot be his own secret Santa, right? So that's what the join criteria is going to be. A.name not equal to B.name. If I go and run this query, see, now you should ideally get, I think, 20. How many entries am I getting? Okay, so there are 6 people. So 30 entries, because for each person, so Aaron will match with all 5 people apart from Aaron. There are 6 people. So Aaron can be, so the secret Santa for Aaron can be anyone except for Aaron. So these are the 5 probable people who can be secret Santa for Aaron. Similarly for James, all people except for James can be his secret Santa. So that's what we are getting. So for each entry in my name column, I can match it to the 5 other names from the same name columns. So that is why you get a total of 30, because it is 6 into 5. 6 is the total number of entries. And for each entry, you can match it to 5 of the other people in that employee table. So that's why it is 6 into 5 here. Okay. So here I'm giving you 2 very simple use cases of self-join. There are some complex ones also. So mostly it is used when you want to process a hierarchy. Here we are processing a hierarchy. There's a hierarchy here. There's a manager and there are employees beneath him. So if I want to understand the manager name tagged to each of these people, this is basically processing a hierarchy, and I'm going to use a self-join here. Second, if we want to keep referring to the same table again and again based on a condition, or we want to find combinations, then we use this. There are other uses also, but for now, to understand self-join, remember, whenever you're joining the same table to itself, then it becomes a self-join. It's about the application where your self-join is different from the other joins. Okay. All right. So we're going to stop here today. In next class, I'm going to talk about a pretty important concept called Windows function. That's going to be the first part. And then we're going to move from there. There's a small part of something called derived table, which we have anyway looked at before using derived table. We've looked at before. This is a concept of subquery itself, but we'll look at it once again. Then we're going to look at indexes. All right, so that's about it, guys. Please start practicing from the question papers, from the practice question paper, which is available to you, and let me know if you have any doubts. I think there was one person, I don't know if he's here right now. Okay, he's not. All right. Okay, so I'll check on that in the next class. Okay, guys, one small thing that I want to be should be there as a part of the recording is that whenever you open up your Google Cloud platform, your BigQuery, you should get something like this, a free trial status. If not, there'll be a small gift box here. Click on that and it will show you the total amount of credit left and for how many days you have that remaining. So this will appear to you if when you activated your Google Cloud Platform account, you added a payment detail. Now, if you had read the terms and condition, it says that this is valid for 90 days, the free trial status. So for me, 16 days in my current account is left. So I started using it almost 3 months back. Now, I just want to point this out to you guys that post the 16 days, if I use anything in this Google Cloud Platform to run any query, to run any services, or to store any of these data sets, it becomes chargeable. Okay. So keep this in mind whenever you guys are nearing the end of your trial period. Make sure that you remove all the data sets and delete all the queries. To keep a note of everything, keep saving it, and then so right now I'm saving everything in a single query. At the end of the session, I'm going to download that entire thing and keep it handy. So you guys can also do that. All right. Thank you so much, guys. It was a good session. I'll talk to you on Thursday. Thank you. Bye-bye.